welcome back. So today we're back here with JCM-1 on the bench for the game update. Now, I've been working on the video controller, as I've talked about in previous videos, but it was being very flustering and just confusing and messing with my head, so I did what any good nerd does when, pressed with a really difficult problem. I'm ignoring it until I have to do something about it. So, JCM-1 here on the bench. This today is going to be the game update. Basically, I have wired up some stuff to make JCM be able to do video games. So let's take a look at that. It's really pretty straightforward. What I've done is I've wired up some game controllers to the Sound 1 chip here to be able to play video games with an actual controller or joystick or something of that matter, because playing with a keyboard is boring. Who wants to do that? So the game input plugs, I've got it wired with two plugs, A and B, and of course they're the standard 9-pin plugs, just like on the Atari or the Commodore 64. As a matter of fact, it matches the same plug input or the same signaling input as an Atari 2600 or Commodore 64 digital input. Now, it doesn't support the analog paddle stuff, but it will support a regular old joystick, so that's cool. How did I get this wired up? Well, let's take a look at that. So primarily, it might be a little hard to see here, but we'll flip JCM-1 over. Basically, I've got the ports wired up here to chip number 1, sound chip number 1, because the sound chips, these 8910s here, have two digital inputs each, which that's basically what they're designed for. They're designed to take joystick input or keyboard input or some other digital pin input. So that's what I've connected those to. As a proof of concept, I also had to make a controller, because when I was designing this, I didn't really have a controller to plug into this. I didn't have a joystick laying around that I could test it with. So I made one. Pretty easy, straightforward controller using some normal clicky buttons. Up, down, left, right, button 3, 2, and 1. Supporting the standard. And of course, they're just wired through ground. So when you press one of these buttons, it pulls that to ground and then grounds it out, and then that way the chip will know you've pressed the button. That's basically all there is to that. So let's discuss basically how this actually functions. So the 8910 has these two these two digital input-output ports, which can be set to either input or output, obviously. So what we do is we will use the VIA to command the sound chip as if we're sending it a sound command, but we're sending it a port command instead. And we say, hey, can you turn both these ports into inputs, please? And when it puts them to inputs, it drives the pins, these pins high. Basically, they have internal pull-up resistors. And then all you have to do is ground the inputs out, then send a register command to the sound chip to say, hey, I want to read what's in the register for the joystick or for that input port, and then it will present that data out to the 6522. Then you put the 6522 in input mode instead of output mode, because we're normally outputting commands to this. We need to put it in read mode so that it will fetch information over its bus. It fetches the information. Then we just go read what's in the register here. In the sound VIA, and that's our data. That tells us what pins are pressed down. Now, the mapping of those pins is like I said, it's the Atari and Commodore 64 standard. Basically, 1 is up, 2 is down, 3 is left, 4 is right, pin 5 is button 3, pin 6 is button 1, pin 7 is voltage, but I don't have pin 7 connected because my controllers that I'm using don't require voltage, because I just have to pull things to ground. So one more reason that it's not compatible with paddles. And pin 8 is the ground line, and pin 9 is button 2. So I just wire those up the same way as they are right there like that, and it just works. So yeah, let's get into the controller a little bit. Now, it's just wired up so that, when you press a button, it pulls each of the wires down, or each of the pins on the controller through ground, and then when you pull the controller and say, hey controller, what's the value of this? You get an 8-bit value where each bit designates effectively what value or what pin is being pulled to ground. So it's all ones when it's inactive, and the active lines turn to 0. The 7th bit, of course, because 7 is VCC, is not connected to these, so that bit never changes. So I, in theory, have that open for another button if I wanted to. Also, if I wanted to forsake the standard, I could use that for another button on special kinds of controllers. So I could have a 4th button here if I wanted to have one. But again, I opted for the standard. Now, this controller is great and all of that, but it's kind of poopy. Trying to play games on this is really a pain in the butt because these buttons really don't have good feel to them. I also, because of that, I could have designed my own controller for use with this, but I thought there's got to be a controller out there that already exists that I can use for this purpose. And there is one. It's called a Nintendo controller. The Nintendo controller has all the buttons and directions and everything that I need to do what I want to do, which is cool. Which means all I have to do is wire up a Nintendo controller with my proper connection type and it'll work. But there is one issue with that. There are really 2 issues. Number 1, I'm not going to bastardize an original Nintendo controller because a Nintendo controller. So this is an aftermarket cheapie, It's just a cheapie. That's okay. It's still as tough as the original. They're really, really strong little controllers. The other side is a problem with that is the NES controller worked by having a shift register inside it that pulled the buttons constantly, and then you would serially fetch the bits out of that controller. So it means I can't wire it directly to the actual controller's internal little brain itself. So what I did is I wired it directly to the pads instead. So my ground line is going to be my ground line still comes up here on the controller to the ground pins of all of these pads, the same as it did. But as you can see with these little solder points, I drilled holes in the controller pad, the controller board here, and just tacked my signal lines onto the positive ends of those pads, so that when you press each button, the button signal will be grounded out by the ground side of the pad, and it works, and it bypasses this chip entirely. And so that allows us to have really nifty controllers that work with this that are actually usable, and not some sort of horrible janky joystick. I really hate joysticks. I like pressy button controllers. So that's basically all there is to the controller setup. It's not very complicated. Pretty straightforward. I just say, hey, give me wire it up. Hey, give me the pins, and then I do some bit twiddling on the data to determine what pins are pressed, and then I can do something with those pins. The downside is because it's not interrupt based, I can't really tell when a button has been pressed. Or anything like that. I have to go out and pull that data and say, hey, give me the button presses. But, on these older computers, it's usually not a problem with the way the design works. You're just, because the human input is so infrequent, you just go out every once in a while and check them, check to see what the button presses are. And by every once in a while, I say every couple of milliseconds is usually fine, because a normal button press is going to be about 10 to 15 milliseconds. So you're going to grab that button multiple times in that time period. So no big deal. So now that we've gone through all of that, what is the absolute purpose and point of controllers? Well, it's to play games, right? Well, JCM-1 doesn't have any games for it, which is a lie that I just told you, because in order to test this, I have programmed a couple games. One is going to remain a secret for now, but the one that is not a secret is Pong. Yes, I programmed good old-fashioned Pong, basically because the game is so insanely simplistic and has the world's simplest state machine. I mean, they used to be able to implement it on logic chips, right? Without even a real processor. It's that simple of a game. So I figured I could bang that out real quick. And I did. I banged it out in about a 3-hour sitting of just twiddling in code one evening, and then I just had to polish it up a little bit. So I got that all done, and I'm gonna show it to you. So you hang out for just a minute. Ha! You just hang out for just a minute while we switch you over to my screen here and we show you Pong. Okay, we have JCM-1 started up here, so let's take a look at Pong. Before I get into that, I actually do want to show you one little feature that I added to make loading programs on JCM-1 easier and faster, and that is a binary load mode. The compiler or assembler that I'm using allows me to output binary files, so I created an input format for JCM-1 to allow it to receive those binary files over the serial connection, which greatly improves the speed of loading programs, especially larger ones. So let's go ahead and do that. That's B mode. I hit B and load binary file. And then all I have to do is send it the actual file over the real-term serial application I use. It'll send it. And there it is. And now we have our program loaded. And I've got my controller connected up here. So we're going to go ahead and try out my Pong program. Now, I only have one controller set up, so the other user is going to die over and over again, but that's okay. So, go 300. Oops, I need to go to the right menu. Go 300. Here we go. Oops, I'm connected to the wrong side. I'm going to lose over and over again. Hold on. I need to change my thing. Yeah, there we go. Up, too bad. You lost left. Oh, wait. Hold on. They won that one. There we go. Are they going to win again? Nope. And we'll do one more quick round here. They're going to be able to ding that again. Now, this Pong is pretty simplistic. As you can see, the angle of the ball does not change. It's always 45-degree angles. I coded it up super fast on a weekend. We'll go ahead and just exit out of the game there. But as you can see, it works, and I can press my buttons on the controller, and it moves my controls up and down and everything. So it works perfectly. So that's really all there is to that. So I'll meet you back over on the bench. Well, that's all there is to that. It's a pretty simple update, you know. Game controllers wired up with a simple binary code input and a game I programmed for JCM-1 to be able to actually do something fun. Yeah, I was just getting bored with trying to deal with that silly video stuff, and I wanted a little bit of a distraction to get my mind off of it so that when I come back to it later, you know, I can come back to it with a clear head. I do that a lot. I'll switch gears and put something that's really flummoxing me. I'll put it to the side and do something a little bit easier and a little bit more fun so that I can clear my head and keep motivated to keep working on the project instead of just putting the whole thing to the side. Another reason why I did this is because I'm going to Kansas Fest this year in 2019, if you're watching this when the video comes back out. And I wanted something to show at Kansas Fest. You know, Kansas Fest is the yearly Apple II festival out at Rockhurst University in Kansas City, Missouri. You know, all us Apple II freaks like to go out there and play around with our Apple II stuff. And, you know, JCM-1 is a 6502 type computer, and I figured I would take it out there and, you know, to just show it off. So if you're going to Kansas Fest this year, come find me. Come to my room or wherever I'm going to be put when I get there. I'm going to have JCM-1 with me, so if you want to sit down and play with it, you can play with it. I'll have instructions on how to use it and the whole 9 yards. It'll be really sweet. While I'm there as well, I'm going to be selling t-shirts. One of these. Yeah, so come to K-Fest. If you see me there, come find me. Buy a t-shirt off me, you know, because 8 bits are all you need. To all of my viewers out there, when I get back from K-Fest, yes, I do plan on putting these t-shirts up for sale on the internet. So stay tuned. If you really have to have an 8 bits are all you need t-shirt, keep a watch out for it, and I will have them available for you shortly. Well, that's all for today's episode. I really hope you enjoyed it. While you're here, click the like button and all the other YouTube bell button comedy stuff because it helps you to know that, you know, my video is liked and that it'll show it to people. And remember that I also have a Patreon page, so if you want to contribute to the museum here to help me keep doing what I am doing, link in the description. Well, that's all for today's episode. While you're here, check out some of my other videos, and remember, 8 bits are all you need.